Hello everyone, hope you all are doing good. Welcome back to yet another topic on ray optics. So I already told you ray optics is a very big chapter. So we will go on with all the important topics. Today's topic is going to be one of the very important topics. As you all know that we have finished so far regarding the reflection at plane mirrors. So plane mirrors lo ఏదైతే లాస్ ఆఫ్ రిఫ్లెక్షన్ ఉంది, వీ హ్యావ్ ఫినిష్డ్ అబౌట్ లాస్ ఆఫ్ రిఫ్లెక్షన్ అండ్ వీ ఆల్సో ఫినిష్డ్ అబౌట్ ద ఇమేజ్ ఫార్మేషన్ ఇన్ ప్లేన్ మిర్రర్స్. సో ఎవరైతే ఈ టాపిక్స్ గురించి ఒకసారి డీటెయిల్డ్గా నేర్చుకోవాలనుకుంటున్నారో, ఫర్ ఆల్ దోస్ పీపుల్ ఐ హ్యావ్ ప్రొవైడెడ్ ద లింక్ ఇన్ ద డిస్క్రిప్షన్ బాక్స్ బిలో. సో ప్లీజ్ గో త్రూ ఆల్ మై ప్రీవియస్ లెక్చర్స్ సో దట్ యువర్ కాన్సెప్ట్స్ ఆర్ మోర్ స్ట్రాంగర్. And today's topic is also about plane mirrors. ఇవాళ ప్లేన్ మిర్రర్స్లో లాస్ట్ లెక్చర్ అవుతుంది. అయితే ఇవాళ టాపిక్లో మనం నేర్చుకునేది ఏంటి అంటే సంథింగ్ అబౌట్ మూవ్మెంట్ ఆఫ్ ఆబ్జెక్ట్ అండ్ ఇమేజ్. సో లెట్ us start our beautiful topic, today's velocity of object and image in my channel Physics Class by KRD ma'am. This is Ramadevi. Let's start our journey again with ray optics. So ఇవాళ టాపిక్ ఏం చెప్పానమ్మా, it is the motion of the object and image. So we put the heading as velocity of image and object. So combined ga chadutamu. So we are going to analyze how to find the velocity of an image. Okay, image velocity ela find out chal. So what is the need? See, all these classes we considered that mirror undi, in front of the mirror object is standing and we are seeing our image. In all the examples we have located the image. Where is the image formed in a plane mirror? What is the size of the image formed in the plane mirror? Lateral inversion ante enti? And we also learned how to locate the coordinates of an image. In all these cases we considered that mirror, object both are at rest. Now is it necessary that the object has to be at rest in mirror? Not necessary. So ee condition lo ivalti class lo what we consider is object is moving in front of the mirror. Now you are standing in front of the mirror, you are looking at your image. When you take a step or two steps towards the mirror, mana mirror వైపు move అయినప్పుడు what do you observe about image? Image కదలకుండా అక్కడే అలాగే ఉండిపోతుంది, మీరు మాత్రం మిర్రర్ వైపు వెళ్ళిపోతున్నారు. No, it never happens. It happens only in horror movies. So original reality లోకి వచ్చేటప్పటికి when we move towards the mirror, the image also appears to be moving towards the mirror. So with what velocity object is moving, with what velocity image is moving, that is what we are going to learn. So మన కాన్సెప్ట్ ఈజీ అవ్వడం కోసం we will divide the topic into different cases. Let us start with case 1. Case 1 కి వెళ్ళే ముందు I have to tell you one very important thing is, ఈ టాపిక్ అంతా కూడా వెక్టార్స్ మీద డిపెండ్ అయి ఉంది. ఎస్, అగైన్ వెక్టార్స్ ఆర్ సీన్. సో ఐ టోల్డ్ యూ వెక్టార్స్ ఈజ్ లైక్ ఆక్సిజన్ టు ఫిజిక్స్ అనమాట. సో ఇట్ ఈస్ వెరీ మచ్ నీడెడ్ టు అండర్స్టాండ్ వెక్టార్స్. Whoever wants to access my vectors topics, please search in my channel. You will get all the important topics related to vectors. So please go through them. And relative velocity, kinematics lo relative velocity ana topic kuda use chestam. So what is the topic we are going to use is, you all know that what is VA, what is VB and what is VAB. Obviously velocity is a vector quantity. VA is nothing but the velocity of A with respect to ground. Velocity of A is an object, B is an object, both are moving. So VA is considered as velocity of object A with respect to ground, and we know that ground always remains at rest, ground doesn't move, so velocity of ground is 0. Similarly, what is VB? It is velocity of B with respect to ground. Then we can write as, what is VAB? How is this read? VAB is velocity of A with respect to B. VAB is velocity of A with respect to B, which is written as VA bar minus VB bar. Do not forget to write these bars. బార్ ఇండికేట్స్ వెక్టార్ ఫార్మ్. సో మనం ఐజేకేల్ని ఇక్కడ సబ్స్టిట్యూట్ చేసుకోవాల్సి వస్తుంది. సిమిలర్లీ ఇఫ్ ఐ రైట్ విబిఏ బార్, velocity of B with respect to A is equal to VB bar minus VA bar. The same concept we are going to apply to find the velocity of image. So దానిని మనం అప్లై చేసేటప్పుడు how are we analyzing? Let us take case 1. Case 1కి వెళ్ళే ముందు again one more consideration, that is we consider all the velocities with respect to ground. Basic velocities, velocity of object, velocity of image and velocity of mirror. All these three are considered with respect to ground, and we all know that ground is always at rest. So velocity of ground is always 0. Now let us start our case 1. Case 1 enti ante the mirror is at rest. Mirror is at rest. So this is our consideration. So when mirror is at rest, we know that velocity of mirror is equal to 0. Mirror is at rest, velocity of mirror is equal to 0. Then the object moves along the normal, or the same sentence can be said as the object moves perpendicular to the plane of the mirror. Both sentences have same meaning. The object moving along the normal, or the object is perpendicular to the plane of the mirror. We all know that normal is drawn perpendicular to the plane of the mirror. This is the plane of the mirror. This is the direction in which normal is moving. That means normal, meaning the direction is perpendicular to the plane of the mirror. So let us just draw a diagram and analyze. My straight line has gone curved. So let us consider a plane mirror, and there is an object. We know that mirror is at rest given. So Vm bar is equal to 0. Now we know that object distance is equal to image distance. So there is an image formed inside the mirror. Object mirror mundu unnappudu kachithanga image anedi it will be formed inside the mirror. So now we considered that the object is moving along the normal or perpendicular to the plane of the mirror. Let us consider this is VO bar. Okay, let us consider this is VO bar. Now when object is moving towards the mirror, in which direction image will move? Image will also move towards the mirror. Manam mirror వైపు వెళ్తుంటే ఆబ్జెక్ట్ మిర్రర్కి దూరంగా వెళ్ళదు. Image also comes towards the mirror. ఎలా తెలుస్తుంది? We already know that object distance must be equal to image distance. Object mirror నుంచి 10 meters distance లో ఉంటే image కూడా mirror నుంచి 10 meter distance లో ఉంటుంది. Now you have taken 2 steps towards the mirror. That means the distance between you and mirror is 8 meters. Then what should be the distance between mirror and image? 8 meters. That means the image is moving towards the mirror when the object is moving towards the mirror. So this is the concept. Now let us write the velocity of image as Vi bar. Now we have to analyze this. How to write VO bar? Or we can find out different situations here. Questions, how possible questions can be made, that we will analyze. So first of all, if you analyze velocity of object with respect to mirror. If I want to find out velocity of object with respect to mirror, so how should I write? Velocity of object with respect to mirror is equal to VO bar minus Vm bar. What is Vm bar? 0. So what is the answer remaining? VO bar. It remains the same. Magnitude same, direction same. That is why bar is written. So please remember, magnitude and VO bar indicates both magnitude and direction. So magnitude remains same, direction also remains same. So that is VO bar. Now let us write velocity of image Velocity of image can be found out with respect to mirror and with respect to object also. We'll see both. First with respect to mirror. So how should I write? Vim bar is equal to Vi bar minus Vm bar. We know that Vm is 0, so it is the same Vi bar. It is the same Vi bar. Now we have to understand one important point here is, with whatever velocity the object is moving, with the same velocity the image also moves. Let us take an example. Manam koncham feel avudam. Let's get some feel over here. This is the object, okay? Now, for example, object has moved 2 meter distance in 2 seconds time. Then, in the same 2 seconds time, object also moves 2 meter distance or not? Because we know object distance is always equal to image distance. Now, calculate velocity of object. Velocity indicating distance displacement by time taken. 2 by 2, 1 meter per second. What is velocity of image? 2 by 2, distance by displacement by time, 1 meter per second. Did we get the same answer or not? Yes, velocity of object is always equal to velocity of image in magnitude wise. Look at the direction. Velocity of object is along positive x direction, velocity of image is along negative x direction. So we need to conclude one important thing, that velocity of object with respect to mirror is equal to minus of velocity of image with respect to mirror. Why did I write minus symbol? It indicates opposite direction. Minus symbol indicates opposite direction. Magnitude wise, if we see, velocity of object is equal to velocity of image, because mirror is at rest. Mirror is at rest, so magnitude of velocity of object is equal to magnitude of velocity of image. This moves 1 meter per second velocity, then this also moves with same 1 meter per second velocity. So this is very important concept to be remembered, because we directly apply this in problems. There is one more point we can write here is, what did we find out here? Velocity of image with respect to mirror we found. Now another question can be possible, that is, can we find out velocity of image with respect to object? Can we find or not? Can we find velocity of image with respect to object? Yes, it is possible. Velocity of image with respect to object is equal to velocity of image bar minus velocity of object. Now we all know that they are equal in magnitude, opposite in direction. So for example, if I consider velocity of image along positive x direction, that is plus I cap, velocity of image negative x direction minus I cap. So let us consider, if velocity of object is some v, then velocity of image is also v, because 1 meter per second, 1 meter per second. So here v is nothing but, let us take 1 meter per second. So how can I write this? Minus vi cap minus vi cap. I hope you understood, because I can write here, I am writing here, velocity of object is equal to magnitude into direction. Direction is positive x direction. Velocity of image is equal to magnitude into what is direction? Minus I cap. So minus vi cap. So velocity of image minus vi cap minus velocity of object plus vi cap. What did we get? Minus 2vi cap. So minus 2v indicates direction, and this is indicated by the, this is magnitude and this is direction. Now if you are asked to find out velocity of object with respect to image, is it possible or not? Yes, because we know that velocity of object and velocity of image are just opposite in direction. Magnitude wise they are same. So only direction changes. So 2vi cap. It is 2vi cap. So this is one method, one case we will analyze. So I hope you are ready with your pen and paper. Please pause the screen and note down. Moving on to the case 2. Let us see about case 2. In case 2, what we consider is, we will change the direction of motion of object. Case 1, we considered object is moving perpendicular to the mirror. Now case 2, object moves along the direction of mirror, along the plane of the mirror, let us say, along the plane of mirror. Again considering mirror is at rest. Even in this case also I am considering mirror at rest. So let us see the example here. So let us draw a mirror. So if I draw a mirror, velocity of mirror is 0. There is an object. There is an image at the same distance. Now in this case, object is moving along the plane of the mirror. So this is the direction of VO bar. Now in which direction the image moves? Hope you remember, we are not watching any horror movie. This is reality. So in image also moves along the same direction. In whatever direction object moves, same direction velocity also moves. Now there is no component along horizontal direction. Both are moving along vertical direction. So when both are moving along vertical direction, here we can write VO bar can be written as VJ cap, positive. If VO bar is VJ cap, V is velocity of object. With whatever velocity the object is moving, with the same velocity image also moves, and what is the direction it is going? It is also going in positive y direction. Now let us write velocity of image with respect to mirror. If I want to find out velocity of image with respect to mirror, velocity of image with respect to mirror is equal to Vi bar minus Vm bar. We know that Vm bar is 0. So what is Vi bar? It is Vj cap. Similarly, velocity of object with respect to mirror, if I want to consider, then velocity of object with respect to mirror is equal to velocity of object minus velocity of mirror. You know velocity of mirror is 0. So it is Vj cap. Velocity of object is Vj cap anukunnam. Now our own concept comes, that is how to find velocity of image with respect to object. Yes, you know velocity of image with respect to object is equal to Vi bar minus Vo bar. What is Vi bar? Vj cap minus what is Vo bar? Vj cap. What is the answer we got? Yes, 0. So in this situation, there is no relative velocity between object and image. So when the object moves parallel to the plane of the mirror, the relative velocity between object and image is 0. So this is relative velocity. That means whatever is the velocity of the object, same magnitude wise, direction wise is the velocity of the image. I hope you all have got it cleared. So now we'll move on to another case. Next case, case 3. So in this case, we'll consider even the mirror is also moving. We will consider the mirror is also moving. So let us consider the mirror is also moving. This is object. Let us consider object is moving in this direction. Then obviously image moves in this direction. This is image velocity. Let us consider the mirror is moving in this direction with Vm bar. So here Vm bar is not equal to 0. So when we write like this, what is Voi cap? Vo bar is Voi cap. It is moving along positive x direction. Next, what is Vm bar? Vm bar is along negative x direction. So Vm into minus I cap. I hope you understand. Similarly, what is Vi bar? Vi bar is also along negative x direction. So it is Vi into minus I cap. So please remember that whenever you are solving problems in velocity of image, please remember first you write down in direction wise. Direction wise I cap, J cap to meeru raseskondi. Then it will help you a lot. Here మనం తీసుకునే లాజిక్ ఏంటి అంటే what we already proved in case 1. Case 1 we already proved that velocity of image with respect to object with respect to mirror will take with respect to mirror bar is equal to minus of velocity of object with respect to mirror. This part we already proved in case 1. So the magnitude wise both are same, direction wise opposite in direction. So let us just substitute. Vi bar minus Vm bar is equal to minus of Vo bar minus Vm bar. Okay, so what is Vi bar minus Vm bar is equal to minus Vo bar minus into minus plus Vm bar. So just rearrange, take this Vm to the other side. So we have Vi bar plus Vo bar is equal to 2Vm bar. So this is a most important conclusion which we use in problems when all the three are moving. When all the three are moving, this is the most important conclusion. Or you can also write Vm bar is equal to Vi bar plus Vo bar by 2. Any of the conclusions you can take. So children, please remember, this is the most important formula you have to use while solving the problem based on all the three are moving, object, image and mirror. When all the three are moving, this is the formula you have to use. Again, E formula lo you have to substitute these values. I hope you understood. Don't worry, we'll take some problems, example problems and we'll prove. So let us move on with our problem so that you can find some application part. We have learned the concept. To strengthen the concept, let us take certain example problems. What are those example problems? Let us start with a easy one. Let me change my pen first. Let me take another pen. So the first example is, there is a mirror which is moving with a velocity 1 meter per second and the object is moving in this direction with a velocity, this is object, 5 meter per second. Now the question is, find the velocity of image. Find the velocity of image. Now, can you solve the question or not? Can you solve the question or not? I'll give you options. Apparao, Baburao, Sinnarao, Durgarao. Apparao says the answer is 7 I cap. Baburao says the answer is minus 7 I cap. Sinnarao says no, the answer is 3 I cap, and the Durgarao says minus 3 I cap. Which is the correct option? Let us select. Let us see how to analyze. So here itself I am drawing. The object is moving with 5 meter per second, meaning the image also moves with 5 meter per second. Shall I write? No, because here mirror is also moving. So let us name the velocity of image as Vi cap. If mirror is at rest, then the answer is minus 5 meter per second I cap. But here mirror is also moving. When object and mirror both are moving, what is the formula we should use? The formula we should use is 2Vm bar is equal to Vi bar plus Vo bar. This is the formula we have to use. So just write down what is Vo bar, Vi bar and all. Vo bar is equal to, this is along positive x direction. So it is 5 I cap meter per second. What is Vm bar? Vm bar is along negative x direction. So you need to write 1 into minus I cap meter per second, that is minus I cap meter per second. This is Vm bar. Now just substitute here. Vi bar is equal to 2Vm bar minus Vo bar. So 2 into Vm bar is only minus I cap minus Vo bar is 5 I cap meter per second. So minus 2 minus 5 minus 7 I cap meter per second. So this is the velocity of image. So who is the winner? Babu Rao is the winner. He says correct answer. So I hope you understood this and you also got the same answer. Now we'll move on to the next example problem. Another example problem let us take. The another example says there is a mirror. Mirror, mirror, mirror. Who is the most beautiful person on the earth? Yes, it is you. Okay, so this is the object. Now, the object is moving with 10 meter per second velocity by making an angle 53 degrees with the horizontal. Now, the mirror is also moving with a velocity 2 meter per second. Now the question is find the velocity of the image. Same question, find the velocity of the image. How to solve? Here, if you observe, the object is neither moving along perpendicular distance nor moving along the vertical distance or along the parallel side of the mirror. Now in such situations, we know that this is a vector quantity. So this is a vector quantity. So a vector quantity can always be resolved into two components whenever it makes an angle with the horizontal. Now resolving this into two components, I am just drawing this here, O, 10 and here it is 53 degrees. So this becomes, this is O. So this part becomes 10 cos 53 degrees and this becomes 10 sin 53 degrees. I hope you understood. So now how can I write VO bar as? VO bar has x component, y component. X component is along positive x axis, y component is along positive y axis. So this is 10 cos 53 into I cap plus 10 sin 53 into j cap along positive y axis. What is cos 53 sin 53? Those who don't know, I always say a short trick. Those who want the trick, please go to my vectors chapter lesson where I explained a short trick how to remember 37 degrees and 57 degrees. So if you just draw a perpendicular 53 here and 4 comes here, 3 and 5. Now what is cos 53? 3 by 5. So 10 into 3 by 5 I cap plus 10 into what is sin 53? 4 by 5 j cap. So this is 5 2 times. So 5 2 times 2 3s are 6 I cap plus 5 2 times it is 8 j cap. What we got is only VO bar, not VI bar. VM bar kuda raskundam. What is VM bar? What is VM bar? Velocity of mirror. Mirror is moving along a negative x-axis direction. Mirror is moving along a negative x-axis direction. So we need to write 2 into minus I cap meter per second. That is equal to minus 2 I cap meter per second. So this is velocity of mirror. Now comes our formula. VI bar is equal to 2 VM bar minus VO bar. From this we write. So 2 into what is VM bar? Minus 2 I cap minus what is VO bar? VO bar is minus 6 I cap plus 8 j cap. Okay, we can write only I components because we already case 2. What does case 2 tells? There is no relative velocity between the parallel components of velocity of object and image. If object has a velocity perpendicular direction length undamma manaki 8 j cap, then image also moves with 8 j cap velocity along positive y direction. So there is no need to write this first of all. So we can write only x component here. I am writing only x components here. So minus 4 minus 6, it is minus 10 I cap. What is vertical component? Vertical component remains the same. Vertical component remains the same from case 2. So how can I conclude now? VI bar is equal to y component is 8 j cap only. Y component remains the same. So now the answer is minus 10 I cap plus 8j k cap. Minus 10 I cap plus 8j k cap. If you want to find out the magnitude, modulus of vi bar, magnitude of velocity of image, then we can write root over 10 square plus 8 square, obviously minus 10 square, but anyway it goes into square. So 100 square plus 64, answer 164 meter per second. So this is how you can find out the magnitude also if it is asked in the question. So I hope you are able to follow all these questions. Let us do one small last problem where mirror and object both are moving by making an angle. A little complicated problem. Let us take. So this is a very small concept but has a good weightage in JEE Mains and NEET as well for asking questions scenario. So let us take one more example problem. Another example is mirror is moving with 5 meter per second velocity and it is making an angle 30 degrees with the horizontal, and then the object is also making an angle and moving with 10 meter per second and making an angle 30 degrees with the horizontal. This is object. Now we need to find the velocity of image. Again the question is find the velocity of image. Find the velocity of the image. So before I start, you have to pause your screens and start doing the problem, then check your answer. So let us start doing the problem. Solution. If you want, I can give you the options also. So but you can solve, I guess. So let us start doing. So here both mirror and object are making an angle and moving. So let us say there is somewhere image here. So first of all, let us write down the velocity of object and velocity of mirror, because our formula is Vi bar is equal to 2 Vm bar minus Vo bar. So Vm enti Vo enti raskoval. So if you just divide this into two components. First let me divide this into two components. This is O. This is 10 meters per second making an angle 30 degrees. So what do we get here? 10 cos 30 degrees, and this side we get 10 sin 30 degrees. This is along positive x direction, this is along positive y direction. So VO bar is equal to along x axis, 10 cos 30 is along positive x axis, so I cap, plus this is along positive y axis, so 10 sin 30 j cap. What is cos 30? Cos 30 is root 3 by 2, 5 times, so 5 root 3 I cap, plus sin 30 is 1 by 2, so we simply get 5 j cap. What is this? VO bar. Next Vm bar. Let us see for mirror again. This is for mirror I am drawing. For mirror the line is like this. This is 5 meter per second. The angle is 30 degrees here. So if you divide into two components, this becomes 5 cos 30 degrees and this part becomes 5 sin 30 degrees. Now see, this is along positive y axis, but this is along negative y axis. So Vm bar is equal to 5 cos 30 along negative x axis. So minus I cap. This is along positive, so 5 sin 30 j cap. Okay. So 5 cos 30 is how much? Cos 30 is root 3 by 2. So 5 root 3 by 2 minus I am taking out I cap. This is sin 30 is 1 by 2. So plus 5 by 2 j cap. Okay. So now it is very simple. The problem is done. Let us write x component and y component of the image. For x component of image, how should we write? Vi bar x component is equal to 2vm bar of x component minus vo bar of x component. Why are we writing only x component? Because from case 2 we already know that the y component of object is nothing but the y component of image. There is no relative velocity. So y component is already decided. Vi of y component is nothing but 5j cap. ఆబ్జెక్ట్ y కాంపొనెంట్ ఏదైతే ఉంటుందో ఇమేజ్కి కూడా అదే y కాంపొనెంట్ ఉంటుంది. సో వీఆర్ రైటింగ్ ఓన్లీ x కాంపొనెంట్స్. సో 2 ఇంటూ వాట్ ఈజ్ మిరర్స్ x కాంపొనెంట్ minus 5 root 3 by 2 I cap minus what is x component here? 5 root 3 I cap, object velocity x component. So now 2 ने 2 को मार दिया, 2 has killed another 2, so minus 5 root 3 I cap minus 5 root 3, sorry we have 5 root 3 here, yes, minus 5 root 3 I cap. So 2 times of 5 root 3, so minus 10 root 3 I cap. I hope I have written everything correct. So this is 10 cos 30, yes, this is 10 sin 30, so we are going correct. So this is 5 root 3. So now we have to write Vi bar is equal to Vi of x component of I cap plus Vi of y component, so y component into j cap. So Vx component is minus 10 root 3 I cap plus y component is 5j